All right, today I'm going to be modifying an already modified Gatton CNC. Tore this bad boy down probably 2 years ago and finally putting it back together with some upgraded parts. This is part one of maybe a 2 or 3 part series on how I'm going to be modifying this and putting it back together and getting it running. So let's get going. Probably one of the hardest parts of this build was keeping my pants up. The amount of bending over that I had to do, insane. I think I need a new belt. Now this table build is really straightforward. It's 4x4s and 2x4s. My last build I went overkill with 2x6s. It's just got a plywood top, and I'm reusing a lot of material from the last build that I had. So just making sure everything fit, and then putting the bracing on afterwards. I want to say that the most time-consuming part of this build was the amount of measuring involved. The measuring and putting together is going to be the most boring to watch as well, I can assume. So in the corner, you can see some pictures. I'll be scrolling through pictures of things that I've made with my old Gatton CNCs. Surprisingly enough, the repeatability of a wood machine is as good or almost as good as a metal machine, and I've owned both. I've built multiple Gattons at this point. They have their shortcomings and their shortfalls, so it's not saying that it's the greatest thing out there, but I don't know that there's any perfect machine out there, period, whether it's made by a company or you make it yourself. If you choose to build a machine yourself, whether it's plywood or a metal machine or whatever, 80-20, it's taking the time to make sure that it's rigid, that it is smooth, and that it's going to do the things that you want it to do. It's just taking the time to do it right. All right, let me hit you up for a second about Amazon Business. It's like regular Amazon, but for small businesses. It's where I got the rails for this build from. It's where I get a lot of my consumables, the boxes for shipping, tape, all that stuff. I get everything from there. It is cheaper than regular Amazon. Not by a ton, but every penny counts when you're in business. So there's a link in the description below. Just check it out, see if it's right for you. So the way this bearing system works is these bearings are stationary, the top ones, and then the bottom ones can adjust up and down utilizing a nut and bolt that's like this, and those are positioned underneath here. And when you screw in the bolt, it pushes up on the bottom of this bolt that's going through, and then we'll raise the whole bearing system up to tighten the rail. If you unscrew the bolt, it'll lower that bearing and then loosen the clamp onto the rail. Here I'm getting all the old hardware taken off of this gantry leg, making room for the installation of these carriages that are going to be put on here instead of those V bearings. One of the things that I didn't do on either of the old machines that I built was put a lot of bracing on it. And I think that's where I got a lot of the wobble from. So this machine, I'm doing just a ton of extra bracing. The carriages need bracing onto the legs, and then the legs onto the gantry itself are going to get bracing as well. I'll show that process in the next video. But I think this is all going to help stiffen up this machine a ton. And with the rails, the addition of the rails, it's just going to make it run a whole lot smoother. Okay, the reason I am rebuilding this machine is it runs off of a V-bearing and aluminum angle system. And you can see here, this aluminum angle is square, but the V bearing is a V where it gets its name, and that rides on top of the aluminum angle. And with the weight of the gantry, because this is a modified Gatton machine, I made it bigger than it's supposed to be. It's constantly wearing on the bearings. The bearings are wearing on the rail, actually. So I was constantly adjusting the machine to make it run smooth and the right way. I mean, I'm not building rocket ships or like highly precise things, but if I do an inlay, I want to be able to put the male piece in the female piece in that pocket, you know, and have it look good. And I just wasn't getting those results, so I tore it down. I ended up buying that Stepcraft D840, and that has had its own problems. That has a slew of freaking problems. It's a love-hate relationship, you know, and buying a big machine, which I want in the shop, at least a 4x4, they're just expensive. So building it is definitely the way to go, and has been the way to go for as long as I've had larger CNC machines. Ooh. So I'm moving to this system where these blocks have a bunch of bearings in them and can move back and forth. And so my gantry is going to ride on this, or both of these, I guess. I got two of them, one for each side. And you can see the profile there of these. I bought these rails on Amazon. I'll link them in the description below. They're relatively inexpensive. These are about 6 feet long, which will give me about a 5.5 by 5.5 cutting area, you know, leaving room for the gantry and the spindle. I'm actually using a router on this. So this last section here is getting the gantry put onto the rails on the table. These three separate components need to go onto the table and work together. So you want to attach one rail to the table at a time. The first rail is essentially going to be a guide for the second rail. So pre-drill your holes, but getting this first rail aligned with the table, the tabletop itself, and then moving the gantry with the other rail not attached will get that rail positioned where it needs to be for smooth movement, essentially. And then you can attach that other rail. Do a victory dance, and yeah. So if you guys have made it this far, thank you so much. I really appreciate it. And we'll catch you on the next one where we start getting motors and rods installed.